Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Okay then guys, so in this one we are going to take a look at solving some quadratic simultaneous equations. Now these are quite hard, but we get lots of marks for them, so they're well worth trying to be able to do. So, download the questions, try them yourselves if you like, or come through them with me. Let's do this. And then first up, we want to solve 2x squared minus y squared is equal to 17, and x add 2y is equal to 1. So the top one is quadratic, bottom one is linear. First step with these guys is to use the linear to get one letter on its own in terms of the other letter. So here, in the bottom one, if we subtract 2y, we get x is 1 minus 2y. Okay. So now that we know what x is in terms of y, we can rewrite the top equation. So 2x squared becomes 2 lots of 1 minus 2y all squared. So the top now becomes 2 lots of 1 minus 2y all squared minus y squared is equal to 17. Okay, now remember, 1 minus 2y squared means 1 minus 2y times 1 minus 2y. So make sure you can get that to be 4y squared minus 4y, add 1, and then the minus y squared on the outside is equal to 17. Okay, so now we're going to multiply through that bracket by 2, so then we have 8y squared minus 8y, add 2, minus y squared is equal to 17. Okay, now on the left we have 8y squared minus y squared, so that's 7y squared minus 8y. Now because this is a quadratic, we need everything on the same side, so I'm also going to subtract 17 from both sides. So 2 minus 17 is minus 15. And that now is all equal to 0. Okay, so now we need to try and factorise this. So, because we have a 7y squared, one bracket is going to need 7y, and the other is going to have a single y. Okay, so the two numbers need to multiply together to minus 15. So one is positive, one is negative. Whatever goes in the second bracket is multiplying 7y. So, we could have, well, if we put a minus 15 in the first bracket, that's multiplying the single y, so that's going to give us minus 15y. And then if we put plus 1 in the second bracket, that's multiplying 7y, which brings us up to minus 8y. So now we can get our solutions for y. So either 7y minus 15 is equal to 0. So 7y is 15. And then divide by 7, y is 15 sevenths. Or in the other one, y plus 1 is 0. So y is minus 1. Now, up to here, we have half the answer. What we now need to do is find the corresponding x values. So remember that we know x is 1 minus 2y. So we're now going to use that with these y values. So when y is 15 over 7, x is 1 minus 2 times that, so 1 minus 30 over 7. Now, 1 whole is 7 sevenths. So this is 7 sevenths minus 30 sevenths. This tells us then that's minus 23 sevenths. And then a bit nicer, when y is minus 1, x is 1 minus 2 times minus 1, so that's 1 add 2, which on a good day is 3. So there are the solutions. Next up we have a nice 6 marker, good times, so 5x minus y is 5, there's our linear, and 2y minus x squared is 11, there's our quadratic. Okay, so first up, from the top one we can get y on its own. So 5x minus y is 5. If we add y, we get 5x is y add 5. And then subtract 5. 5x minus 5 is y. Okay, so now we substitute that into the second equation. So 2y becomes 2 lots of 5x minus 5 minus x squared is equal to 11. Okay, so let's expand the brackets. We're going to get 10x minus 10 minus x squared is equal to 11. Okay, so we don't really want a negative x squared term, so we're going to move everything over to the right. So to do that, so we're going to end up with a 0 on the left, so we're going to add x squared to both sides. We're going to subtract 10x, and we're going to add 10. So 11 add 10 is 21. Okay, so now we need to factorise that. So that factorises to x minus 3 times x minus 7. So that is equal to 0. Now that then tells us x is 3 or x is 7. Okay, now we need to find our y values. So remember at the start we said y is 5x minus 5. So when x is 3, y is 5 times 3, which is 15, minus 5 is 10. And when x is 7, y is 5 times 7, 35, minus 5, 30. Boom. Okay, next up, a curve has equation y equals 4x squared add 5x add 3. A line has equation y equals x add 2. Show that the curve and the line have exactly one point of intersection. So, the whole point of solving simultaneous equations, when it's purely algebraic, is to find where lines or curves meet. So, we need to solve these simultaneously and show there's only one solution. Now, here, because both equations already have y on their own, so we know that y is 4x squared add 5x add 3, and y is x add 2. That means at intersection points, then we know, again, because they are both explicitly in terms of y, we now know 4x squared add 5x add 3 would be equal to x add 2. So, all that we're really saying here is that y is equal to y. We're just choosing the right hand side. So, to solve quadratics, we need them equal to 0. So we're going to subtract x and subtract 2 from both sides. So we're going to get 4x squared add 4x add 1 is equal to 0. Okay, now let's see if we can factorize this. So, we know the two numbers at the end have to multiply together to 1. Now, everything in the quadratic is positive, so that really restricts us to 1 and 1. Now we need to end up with a 4x squared and a 4x in the middle. So the way we're going to do that is with 2x and 2x. Now we can write this then as 2x add 1 squared is equal to 0. Now this tells us then that the only point, or the only x coordinate, would be when 2x add 1 is equal to 0. So you could stop here and say, okay, there's only one x coordinate where the line and the curve intersect, therefore they only meet once. We're going to go all the way though and solve completely. So 2x add 1 is equal to 0, so 2x is minus 1, which means x is minus 1/2. Now remember, we also know y is x add 2. So, when x is minus 1/2, y is minus 1/2 add 2. So, if you like, minus 0.5 add 2 is 1.5. So, we're going to call that 3/2. So, the only intersection point is at minus 1/2, 3/2. So, the straight line is a tangent to the curve. Okay, next up, the line y equals 3x add b, and the circle x squared add y squared is equal to 53 intersect at points A and B. B is a positive integer, so a positive whole number. Show that the x coordinates of points A and B satisfy the equation 10x squared add 6px add b squared minus 53 is equal to 0. Okay, so that might seem strange. We're just doing what we've been doing in the other questions. We're substituting the linear into the quadratic. So, we know y is 3x add b. So, we're going to put that into y squared in the circle. So we get x squared add 3x add b all squared is equal to 53. So we have x squared. Now remember, this means 3x add b times 3x add b. Okay, so we have x squared. Now 3x times 3x is 9x squared. 3x times p is 3px. Now we're going to get that twice, so that's 6px. And then add p squared. So that's 53 3. So altogether we have 10x squared. Add 6px. Add p squared. Now, the last thing to do is subtract 53 from both sides. So that is what we were trying to show. Okay, then for part B, we are told the coordinates of A are 2, 7. Work out the coordinates of B. Okay, so remember that we know y is 3x add p. Now that we're told there is this point 2, 7, that means when x is 2, y is 7. So this is going to allow us to work out the value of p. So when x is 2 and y is 7, we get 7 is equal to 6 add p. So it turns out then p is just 1. So now what we can do is substitute that into what we've just shown in part A. So 10x squared add 6px add p squared minus 53 is equal to 0 now becomes 10x squared add 6x add 1 minus 53. So that gives us minus 52 is equal to 0. Okay, now this quadratic has a common factor of 2, so we can divide 3 by 2. We're going to get 5x squared add 3x minus 26 is equal to 0. Now let's try and factorise that. So because we have a 5x squared, we're going to need a 5x. And then an x in the other bracket. Okay, now at this point, this might be looking a bit tricky to factorise. Think about it though, we already know x equals 2 is a solution. That means we need x minus 2 in factorised form. So in this bracket is going to have x minus 2. Now to get the minus 26 at the end, the other bracket needs a plus 13. So let's just check that. If we expand this out, 13 times x is 13x, minus 2 times 5x is minus 10x. Altogether then, that gives us the plus 3x that we need. So, now we can get the other x solution from the first bracket. So, for this whole thing to equal 0, 5x add 13 would have to be 0, or x minus 2 would equal 0. We know the solution from that there. So 5x add 13 equals 0. Subtract 13. 5x is minus 13. Divide by 5. Now if we do this as a decimal, probably easiest, minus 13 over 5 is minus 2.6. Okay, so that is the x coordinate of B. Now we need to find the y coordinate. So remember, y is 3x add p. We now know p is 1. So y is 3x add 1. Now when x is minus 2.6, y is going to be 3 times minus 2.6, which is minus 7.8, add 1, which is minus 6.8. So the coordinates of B are minus 2.6 minus 6.8. Okay, now the final question. This one is hard. So, x squared minus 4y squared is equal to 9. 3x add 4y is equal to 7. So what makes this hard is the linear equation. Whatever we do to it, it just isn't very nice. So, because up in the top equation, x squared is simpler than 4y squared, I'm going to get the x on its own. So, from the linear, 3x is 7 minus 4y. So x is 7 minus 4y all over 3. So substitute that into x squared above, and believe it or not, we get 7 minus 4y over 3 all squared minus 4y squared is equal to 9. Okay, now at this point it's nice to remember a fraction to a power can be split into the top to that power over the bottom to that power. So we can write the fraction as 7 minus 4y squared over 3 squared, which is 9, minus 4y squared is equal to 9. Now let's get rid of the fraction by multiplying through by 9. So we're then going to get 7 minus 4y squared minus 36y squared is equal to 81. Okay, next we're going to expand these brackets. So again, remember this means 7 minus 4y times 7 minus 4y. So make sure you can get 16y squared minus 56y add 49 minus 36y squared is equal to 81. Okay, now 16y squared minus 36y squared is minus 20y squared minus 56y. Add 49 is equal to 81. Okay, so either now we can think about moving everything over to the right, or can I show you another way we can think about it? So, let's say we can't be asked to move 3 terms over to the right. So instead, we're going to subtract the 81. So that's going to give us minus 20y squared minus 56y. And then 49 minus 81 is minus 32. So that now is equal to 0. Okay, now what we can do at this point essentially is multiply everything by minus 1. So we're going to get 20y squared, add 56y, add 32 is equal to 0. Okay, now here we have a common factor of 4. So divide through by that, we get 5y squared add 14y, add 8 is equal to 0. Okay, so now it's time to try and factorize this. So we're going to need a 5y and a y. Okay, so how can we factorize this? Well, if we put a plus 2 there, that's multiplying 5y, so that's getting us 10y, and then if we put plus 4 there, it works. Okay, so finally we can get our y solutions. So either 5y add 4 is equal to 0, 5y is minus 4, so y is minus 4/5, or probably going to be easier here to work in decimal, so it's minus 0.8. Or from the other bracket, y plus 2 is 0, so y is minus 2. Okay, so that's half the answer, but most of the work. So remember, x was 7 minus 4y over 3. So we're now going to use that with these two values of y. So when y is minus 0.8, x is 7 minus 4 lots of minus 0.8. So that's 7 add 3.2, which is 10.2, and then that divided by 3 is 3.4. And then when y is minus 2, x is 7 minus 4 lots of minus 2, so that's add 8. So 7 add 8 is 15, divided by 3 is 5. Boom. Okay then guys, that's the end of this one. Really hope you found it useful. It's quite tricky stuff. If you want more of them, let me know. If you have any requests or topics you want done like this, also let me know. If you have found it useful, please do give us a thumbs up, get subscribed to the channel, share with your friends, and have a great day.